next part that we're going to deal with in this beam deflection example is, now that we have the boundary and continuity conditions and we have the moment diagram, let's now go get the moment curvature. Now, we're not told anything about the E and I of the beam, so we kind of have to assume that it's constant, but that is absolutely an assumption here because it wasn't told to us. That would be pretty common, that it would be all the same material and the same beam size all the way along the length. Right, so if that's constant, then our moment curvature is that our curvature kappa will be equal to m over EI, or you can rewrite that also as, of course, EI kappa is equal to our moment. There's our moment functions. It's a little easier to work with this one, because our next step then is, well, let's go find what the slope is. All right, now remember the symbol for slope is theta, in that d theta dx is equal to kappa, so therefore theta is equal to integral of kappa dx. Well, but kappa is equal to m over EI, and m is two different equations, so we got two different segments. This becomes a pretty big, gigantic pain to deal with here. So we'll have to integrate this twice. Oh, this is really a pain. Right? So we have segment 1, and we've got segment 2, and it is oftentimes so much easier. Let's multiply by a constant, EI theta. It's not going to change anything, and that'll be equal to integral EI kappa dx, and so that makes, because kappa is equal to m over EI multiplied by EI, it goes away for now, and so now when we look at these two, we'll have px over 2 integral dx for the first one. The second one would be then integral of minus then px over 2 plus PL over 2, all of that times dx. Right? A little bit easier to work with when you do it that way. The first one becomes px squared over 4 plus a constant of integration. And the second one is minus px squared over 4 plus PL over 2 times x plus another constant of integration. Oh, that stinks. And guess what? We don't know the slope anywhere, so we can't solve for those. We have to move on to another step.